Have you ever found yourself gazing at a thunderstorm, marveling at the jagged paths of lightning across the sky and wondered, why doesn't lightning travel in a straight line? It's an intriguing thought, isn't it? The brilliant streaks of electricity that light up the sky, their paths twisting and turning, defying logic and our understanding of nature. Why, indeed, does lightning choose such a complex route rather than a simple straight line? Well, you're not alone. It's a question that has puzzled many. Today we delve into the science behind this fascinating phenomenon. To understand why lightning takes such a zigzag route, we first need to grasp what lightning is and how it forms. Lightning is a spectacular and powerful natural phenomenon that we've all witnessed. But behind this flashing spectacle, there's a fascinating science. So, what is lightning? In simple terms, it's an electric discharge caused by imbalances between storm clouds and the ground, or within the clouds themselves. But how does it form? As storm clouds develop, there's a constant movement of tiny ice and water particles. The friction from these particles moving against each other creates an electrical charge. Over time, the entire cloud fills up with electrical energy. But this energy doesn't stay trapped in the cloud. It seeks a path to discharge, typically towards the ground. Ground objects like trees, buildings, and even the ground itself act as grounding points for this energy. The energy moves towards these grounding points in a process we see as the brilliant flash of a lightning bolt. But here's the catch. This energy doesn't move in a straight line. Instead, it moves in a jagged zigzag path, which is what gives lightning its distinctive fork-like appearance. So that's how lightning forms. But why the zigzag path? Why not a straight line? Let's explore. The zigzag pattern of lightning, also known as a stepped leader, is essentially a path of ionized air. It's a breathtaking spectacle of nature that leaves us in awe. But have you ever wondered why it doesn't just take the shortest route to the ground? Why all the zigzagging? Well, it all begins with a charged cloud. As the negatively charged particles in the cloud seek a more positive area, they begin to inch their way down towards the Earth. It's not a smooth descent though, and here's where things get interesting. The path of lightning is heavily influenced by a variety of factors such as air density, temperature, and the presence of dust or other particles. These variables create a dynamic and irregular landscape for the lightning to navigate. You see, the air isn't the same everywhere. Each slight variation, each minute change in temperature or density, can alter the path that the electrical discharge will follow. Lightning, in essence, feels its way towards the ground. I know it's a strange concept to grasp, but imagine if you were in a dark room filled with obstacles. You'd extend your hands, trying to feel your way around, right? That's what lightning does. It sends out these feelers, these leaders, branching out in all directions. These leaders follow the path of least resistance. They're attracted to areas where the air is more conductive, where it's easier for them to travel. It's a bit like water flowing down a hill. The water doesn't flow in a straight line. It twists and turns, following the contours of the land. Similarly, the lightning twists and turns, forming its signature zigzag pattern as it seeks the easiest route downward. And there you have it. The zigzag pattern of lightning is not some random phenomena. It's a progressive, complex process guided by the very nature of our atmosphere. So, it's the imperfections in the atmosphere that guide lightning on its jagged journey, not a straight line. So, to wrap up our electrifying discussion, let's revisit the key points we've covered. Lightning, that impressive streak of bright light in a thunderstorm, is formed when electrical charges within a cloud find a path to release their energy. But why doesn't this path go straight down? Well, it's all about the atmospheric conditions. The air isn't uniform, it's a mix of different gases, particles, and varying temperatures and humidity levels. All these factors create a kind of obstacle course for the lightning. As the electric charge moves, it seeks the path of least resistance, often zigzagging its way through these atmospheric conditions. So it's not some random design or nature being artistic. It's the science of electricity navigating through a complex environment. Each lightning bolt is a unique journey, guided by the specific conditions present at that moment. So next time you see a lightning bolt zigzagging across the sky, you'll know it's not just nature's light show, but a fascinating display of science in action.